Hello and welcome to my shop. This is Jim Dedman, Sawlogs Plastic Hubs. Hope you enjoyed today's video. We'll be doing something interesting, so hang around. Let's have fun. One thing I forgot to mention the other day, bring you up closer, is if you'll notice I'm using one of the tools that uses the side of the insert. Part of the reason behind it, I had to do it for setup purposes, and the other reason behind it, to be quite frankly, is I'm cutting so much material off, I'm wiring the inserts out. So I'm using the insert sides that I normally wouldn't use, and that's a bonus right there. Okay, I've got my facing tool in, and we're going to face this thing down to just make sure it trues up good, and then we'll have this plate pretty much ready. We may go back in later and turn the OD. I'm going to try something. Hold on. We're going to try a little bit. We're going to try to hit it at about 200 RPM. Take a very light skim cut down the face here, just to make sure we're getting it true to the spindle. And we'll take a file and break the edges. We'll clean up some more. I just vacuumed up enough to change tools and whatnot. And I stopped and worked on my air compressor a little bit today too. In case you don't understand, I got a Harbor Freight now, and if it's under 60 degrees, it don't like to start. That kicks the breaker out. Well, I decided there was a way to fix that problem. I took it apart and bypassed the little breaker on the machine, because if it pulls too many amps, it'll hit the circuit breaker in the shop. And therefore, I ain't got to worry about it, because I don't have the space to have it inside, nor do I want the noise. So, I'll bring you back and give you a final view after I get this done. Now, there's where I'm at. We'll stop. This is about 6.5 inches right now. I'm not completely sure that we'll turn this anymore. It'll just depend once we get the piece of steel. So the next, I'm waiting on the steel to get here. It'll be a few days. So I went ahead and ordered it on eBay, because it's kind of a wash, and you know, if you're buying, unless I could get lucky and go down there and dig in a scrap bin, and so I'm knowing what I'm needing is a 7. I'm gonna start with a square and round the edges off and turn it, because a round piece would be prohibitively expensive. So it's a little over 1 inch thick we need. So what we're going to do is we're going to turn them. We'll mount it to this and actually fit it to this, have it to hold. You'll see eventually. But this is already true to the spindle, as true as I can get it cut down. So that's all that's important. Okay. Yeah, I have a mission should I choose to accept it. Well, I'm being silly. We're not Mission Impossible here today. I'm continuing on with my drive dog plate build. And in an earlier video, you've seen that I took a back plate and I have a center that fits my lathe. So I need basically a spacer piece to make up the distance. So it's going to be a fairly thick, and this one's going to be a 2-piece. I decided to use steel because I wanted the wire resistance. It's going to be a little heavy. So what we're going to do today is take this square plate, make a round hole plate out of it. So the first step, we got to get a hole in the center so we can mount it in the lathe, and obviously we're going to knock the edges off and a few other odd and end sundry things today. So I got the drills laid out over there to the side, if you'll notice. So we're just going to punch a hole in this and start it. I've laid this out. So now what I'm going to do now is get my bandsaw out. You can see I've laid it out to somewhat of a circle. What I'm going to do is take the bandsaw and rough this out. What I'm going to do is I'll mark this out. I'm going to take this bandsaw and rough these edges off. And that's kind of the plan. I'm not going to bore you with me sawing on this thing. I might turn the mic off and saw just a bit. Right here's the first corner cut off. Now we'll start on the next. We're just going to kind of rough them out so we don't have to pop all these edges off when we make this a round piece. So I'm going to continue sawing. You kind of get the idea of what I'm doing. That's 2 corners sawed off. Basically what we're doing is just sawing around it and getting it somewhat round. Once we put it on that mandrel, we'll cure it up. The advantage, first, this is inch thick material. And I could have got my oxyacetylene and cut this, and I'll tell you that. However, you do all this work hardening. With this, I'm not work hardening it and get these edges off. And so it's going to, you know, again, I just happen to got, you know, hindsight being 20/20, maybe I could just order a 6.5 inch piece of material from metal supermarkets right out the gate and, you know, had it sawed. What it cost me as much as this plate, who knows? I mean, I probably saved $10 or $12 by buying this plate, but I've got the time too, so that's another thing you got to factor in. That's not round. I'm not even going to promise you to say that. But what that'll do is when I start to turn this, it's still going to be kind of oblongish and stuff, and we're going to take such light cuts anyway, but that eliminates a lot of work trying to turn all these corners off. So basically, what I did was just drill the center this up on the mill, and you've seen this, and drill the hole. Then I just took my calipers and just sort of laid it out, the distances to the squares. So this has got to be a lot smaller anyway, so I'm just kind of leaving me some room to work. So let's get set up. All right, I'm going to give you another view. Basically what we're doing is taking very, very light cuts. We can only take about 20 thousandths a pass with this setup. It's basically a 1-inch bolt that goes through it. What we're doing was just more or less trying to get this to be a circle, and it kind of gets to be a little bit of a challenge when you're working with it. And like I told you when I laid it out, it wasn't going to be perfect, but this is the way you got to do it. Steel presents its own unique challenge, and this is probably A36. Again, I don't know if I saved any money or not, but I'm experimenting, and I don't want this plate. And I had this plate on, well, I picked this plate up for this purpose, but I could have used a 6.5 inch round plate, which is I'm going to end up making this to at least close to 6.5 inches when I get done with it. I just got to be very, very patient and only take very light cuts to this setup, because there's just, you got like a twisting action, because you're really not holding on very much to do this. And you'll notice I got a left-hand tool in there and the lathe turned around and all kind of stuff to get to it. So you just got to take these light cuts. I'll get this thing round, I'll bring you back. Alright, I'm going to show you a little cutting action here. We're taking this round blank down to a pretty good size, and basically I want the size of the back plate, which is about a little over 6.5 inches, and we've been machining on it a while. There's some what I want to tell you, there's going to be some what you would call time lapse of doing some of the passes. This is a pretty slow process, so I'm still liking a good bit. We can only take a certain amount of stock off. This lathe just doesn't have that much power, so you can see And we're straining. You can hear it when it goes in. We're not taking A-bomb cuts, but you can hear her talking. Like I say, you just start from a blank and just keep whittling away at it. You'll get it down there. Kind of chip control is kind of hicky at this setup. I get her down there closer and I'll probably change the tooling around. I'll probably turn the OD like this. I've actually had to take the nuts, if you can't see it in there. There's tack welding them, because I had to do that to get them to hold. But I thought I'd let you see a little bit of heavy metal machining, grizzly style. So this is like I say, that mission that I wanted to accept. Okay, we've cleaned this up or machined it down. What I ended up having to do was to tack weld this. So what I did is I just took a tool and lathe and went down near that nut and machined that tack weld right off to be able to turn this down. So now this is turned down to match this. Now still we got to do some facing and some other work. And obviously bore it so that the center go through it and put everything. But now we have a rough blank. It's going to take about that much. Probably this will be stepped into this about 1/4 inch here eventually. So we got a lot more machining to do. But now we've got something to work with. So that's where we're at. Starting the facing cut here. I'm not going to bore you. We're going to be running a time lapse on this operation here for the video, but it'll be blended in. So I'm just taking the first cut here to see where I'm at, true it up. And if you notice, it's got like the bore's a little bit out of round, just don't worry about it, because we're going to bore this anyway. What it was, by the way, there was like 20 or 30 thousand slack in the arbor. So we turned everything, you know. The 1-inch drill didn't drill exactly 1 inch. It drilled about 30 thousandths over. So we got that to deal with too. So right now all we're doing is just cleaning this face up to begin with. And then we're going to work on the other project there of doing the other. Bring you back a little later. What I'm wanting is to machine this out. Let me kind of get it up here where it touches. My original plan, and I'm just going to go back to it, is I want this plate here that's bolted into the back plate to stick out 3/4 of an inch. So the way my figuring was is give me about a 1/4 inch lip inside the back plate, which I'm turning down now. Thought about an 1/8 to give myself more, but if I have a little bigger gap, when I measured it, 3/4 would work pretty good for us. And what I'll do is we'll check everything out in a little while. We'll get it put together, kind of we'll dry fit it. We got to go back and do any extra machining before we put the slots and stuff in it, and the bowl holes, to bolt everything together. We can't. But my plan is I'd rather if I have a 1/16 or 1/16 of an inch more stick out of the tailstock, it's not going to be a crime. of the center, excuse me. So right now I've just discovered by cutting the spindle speed down to the slowest of the lathe has and taking 50 thousandths cuts, so we'll get it done. I should be within about, I got this pass and one more, and then I should be able to take a 30 thousandths finishing pass. So if you see with that RPM and feed rate I'm running, I'm getting a nice chip break. You'll look down there, so I'm pretty satisfied with it. We're boring. Now we got to take this thing out to basically about almost a little over 1 3/4 for this tailstock to fit through at its biggest diameter, center. So what we're doing right now is just sort of roughing it out. I know I've got a good ways to go, so we're going to put a little cutting oil in it and just do some cuts. We're having the board about 360. Lathe needs this steel is really tough. And this torque on the boring bar is pretty good. So this is the biggest small boring bar I have. This is one of them Anderson flea market specials that I picked up several years ago. Use this little small D&MG inserts. But this is like a 3/4 inch, just about like the biggest little bar I got. And I've got bigger bars, but we're just going to rough this thing out. I'll bring you back. All right, you should be seeing the last pass. If my math's right, I should be pretty close, within a couple of thousandths of this diameter. That's what we're going to check instead of measuring it. Now, always when I'm boring stuff like this, I what I call back bore them out. That way I get like a spring pass coming out. And I do all my measurements based on this back bore coming out. What that does is make sure in my mind that I've got all the spring out of it. So it also gives me like a finishing pass on the way out. So we will see here in just a second. And I'm just calipering these because this is not like it's got to be a press fit. This has just got to be a loose enough fit for this to slide through there effectively, and we're looking to be, a little bigger than the other. All right, that center should go through there with a little bit of clearance. We'll see here, move this chip. Oh yeah. See, that's good. That center's just got to slide through there at the biggest end. That's all we need. Okie dokie. Now all we got to do is sort of deburr it. What I'm going to do for the front is since this bar is kind of an angle, I'm going to try to run it through there and just catch it in the front. Pull it back. cut a chamfer thin, and then we'll try to do something different here in the back. Okay. Ooh. What we'll have to try to do here, because this is pretty tough material, we're going to have to try to do this. This is a tricky thing to do, what I'm fixing to do. Just put a little blend right there. That way it'll kind of make it have no burr here going in or both ways, and then we'll, so that should get us right there. Take it off, have us a look. Boys and girls, ladies and gentlemen, this is what we got. Now, this is the whole assembly for the drive plate. This is what it's going to be like. Basically, this is the back plate that I machined down out of cast. And that way I have all my angles. Then I have this that sits on there like this. So what I'll need to figure out in the next video, or next time we get together to see all this, is we're going to put the slot for the drive, a slot for the bolt, and then we're going to put a 4-hole bolt pattern to bolt this together. So this will be the whole assembly. This goes up, then the center goes in. So this has got slight clearance. I'll show you in just a second. I'm back. See that? This slides in there. It's a few thousandths clearance. That's what the intention was. So that's the way this whole system is going to work. It's more or less designed, not designed, calculated. And I'm going to give you a chuck update. You probably see, I'll probably give you an update on the chuck. And I'll do that separately. I hope you enjoyed the video. So let's put a disclaimer out of the way. This video is my idea how to do things. It's not the only way. So I hope you enjoyed it today. The other thing, comments are always welcome. Please take the time, if you feel so inclined, to make a comment on my videos. Also, I appreciate all my subscribers, the new ones and the new ones. And finally, the other disclaimer. This is a copyrighted production of James Dedman, Sawlogs Plastic Hubs, for your enjoyment on YouTube. Thank you. Have a great day, and we will see you in the next video.